Good morning, everyone. Hope you guys are doing well. It's been rainy these past couple of days, but it's nice out now, which is kind of a bummer because I'm making this video. I'm about to go for a bike ride afterwards, hopefully. Today, we're going to talk about area of regular polygons, and we're going to go over a little vocabulary first, and then we'll kind of go into some examples. This should be a fairly short video. We'll see. Okay, so area of a regular polygon. So we have this figure A, B, C, D, E, F. It is a regular hexagon. And as we can tell from the picture, it is inscribed in the circle. So inscribed in the circle, and then circle G is centered about the figure. All right, so if we look at the figure, we can see AG, so here is the radius of the circle, and the distance from the center to a vertex. And then if we look at angle AGF, if you remember from the last unit, that is a central angle. And then we can figure out what that measure is. So if we know it's a regular figure, all these sides are the same, they're all congruent, and so we can just take these triangle, count out how many there are, there's 6 of them, divide by 360, and so we get 60 degrees. So let me just zoom in here, so we're talking about this angle here. So 60 degrees. And then the perimeter, so we're going to generalize this because we don't know anything about the lengths. Excuse me. So that is the number of sides n times s, the side length of one of those triangles. So let me just write that out. So n is equal to number of sides, where s is equal to the one side length. Okay. So we're going to be using all this information in a little bit. So the apothem, what is it? It's the perpendicular distance from the center to any side of the polygon. So we're talking about this here. We can see it's perpendicular because we have the right angle there. All right, so now let's kind of calculate a couple things here. I'm going to erase what I drew in, and I'm going to use red. So we're talking about the area of the red triangle. So we're talking about this area here. We want to calculate what that area is. And if we can do that, then we can pretty easily figure out what the rest of the hexagon area is. So what is that? Well, that's just the area of a triangle, 1/2 base times height. In this case, the base is s, and the height is a. So 1/2 s times a. And now what is the area of the hexagon? Well, how many triangles do we have? We have 1, 2, 3, 4, 5, 6. So we can just multiply that by 6. But in general, we can say, well, it's the number of triangles or number of sides times the one triangle. So what we can say is n times 1/2 s times a. So the number of sides or the number of triangles times one triangle is equal to the area of the hexagon. And then we need to think about, we can make this just a little bit simpler and say, okay, what is perimeter? Perimeter is the side lengths. It's all of this. So that's S, S, and so on. So what we have then is the perimeter P is equal to the side lengths times N, the number of sides. And so we can substitute that in this equation here. So what we end up with is the area of the hexagon is 1/2 A times P, where P is the perimeter and A is the apothem. And we'll see on the next slide that that's exactly what we come up with. So 1/2 A times P. Did I skip? Hold on one sec. Let me just make sure. I forgot to include a slide. That slide that you're looking at right now is Theorem 10.6, and that just summarizes everything we just said. That A is equal to 1/2 N times 1/2 AS, and then we substitute that in to get 1/2 A times P. Sorry for the confusion. Okay, so let's look at kind of the steps involved with this. So if we want to find the area of a regular pentagon with a perimeter of 40 centimeters. Okay, so perimeter P is equal to 40. So the first thing we want to do is find the apothem. Okay, so let's think about how we might do that. So if we take a look at this figure here, we know the perimeter is 40. Well, how many triangles do we have? We have 5. So if we divide by 5, we get 8. So that represents one side length. Or we can think about that as S. S is equal to 8. And then if we draw an apothem here, make it perpendicular, we need to figure out what that is. So now we need to do a little calculations here. So we want to know what one of these angle measures is. And so if we just take 360 divided by 5, we get 72. So that's 72 degrees. But that's not the exact angle that we want. We want, let me use blue here. We want this angle right here. So 72 divided by 2, that's, well, we get, let me make it a little smaller, 36 degrees. So 36 degrees. And then we know this is 4 and 4. And we're looking for A. So what we can do is we can use a little trig to find A. If this is our reference angle 36, 4 is the opposite and A is the adjacent. So we can say the tangent of 36 degrees is equal to 4 over A. Let me write that a little neater. And then we can solve for A. So A is equal to 4 over the tangent of 36 degrees. And that comes out to roughly 5.5. So check with your calculator to make sure you get that same thing. So now we found the apothem. So A is equal to 5.5. Second step, we want to find the perimeter. Fortunately for us, we already know the perimeter. It's already given to us. P is equal to 40. And then we want to find the area. of figure. Ooh. So 1/2 A times P. So 1/2 the apothem, which is 5.5, times the perimeter, which is 40. And we get 110 centimeters squared. And there's our answer. All right, let's look at 2 or 3 other examples. All right, so first example, find the number of sides of a regular polygon with a central angle of 90. Okay, so now we need to think about kind of what that means. That means if we have some circle here with a center here, and if this is 90 degrees here, then what kind of figure would that be? Well, that ends up being a square where we all have 90 degrees. Didn't have to draw all those right angle notation, but we get the point. So there's 4 sides. So the answer is 4. That one was pretty easy. All right. Second example, find the area of a regular octagon with an apothem of 60.4 inches and a side length S of 50. Well, let's first draw. Let's see if I can draw this. I did a little practice before this. So we have that here. Okay, so there is my makeshift octagon. And what information are we given? We're given that the apothem, so let's call that the center, that is 60.4. And then it says the side length is 50. So what are we missing here? We're missing the perimeter. So the perimeter, P, is equal to the number of sides times the side length. Well, there's 8 times 50, so we get 400 inches is the perimeter. And then we can calculate the area because we already know A. We know A and now we know P. So the area, capital A, 1/2 A times P, 1/2 times 60.4 times 50. And that comes out to, oh, just kidding, not 50. Perimeter is 400. There we go, that looks a little better. So we get quite a large number, 12,080. Is it centimeters? Nope, it's inches. Inches squared. And so we could have figured out what that side length was if we weren't given it, basically by finding the angle measure here. So let me just draw that real quick. If we weren't given that side length, if we know this is 60.4, we could calculate what this angle up top here is by taking 360 divided by 8, so getting 45, and then dividing that by 2, and we get 22.5 degrees for this right there. And then we can use trig again to find this side down here. And then multiply that by 2, and then we get S. And then the last one, find the length of the apothem of a regular hexagon with a radius of 8. So let's draw it down here. Okay, so we have hexagon, Not too bad, right? All right, so we have a radius of 8. So what does that mean? That means it goes from the center to one of the vertices. So that's 8. Excuse me. This is also 8. And then we want to figure out the length of the apothem. So we want to know this. That length there. Call that A. So we want to find A. Well, pause it and see if you can figure it out. All right, let's see if you got it. So, excuse me, we need to know some angles. So it's a hexagon, so each of these triangles, the central angles are 60 degrees. So here is 60 degrees. But we don't want to know that whole angle, we want to know half of it. So there's 30 degrees. We also know by definition the apothem is perpendicular. So if this is 90, that's 30. The angle down here will be 60 degrees. And then it's a 30, 60, 90 triangle. So let me draw that triangle out a little bit neater separately. So what we have then is this. So we have 8. We have 30 and 60. If you remember the rules, so 2x, x root 3. So if 2x represents 8, then x represents 4, and then this apothem A represents 4 root 3. And that's all I was asking. So find the apothem. There's our answer. So A is equal to 4 root 3. And that's it. So that's all we're going to learn today. I'm going to attach another sheet to work out a couple problems. Yeah, that's it. Hope you guys have a great day. And take care.